Now that we're done talking about strings and other data types, let's talk about how we actually store the input. The first thing to note is if we're going to make any changes to our data, it has to be stored in memory first. We've talked about this. So if we do some input, it has to be stored in memory before we can do any changes, any manipulations whatsoever. So how do we get it into the memory? Well, two steps are needed to make this work. The first step is we need to instruct the computer to allocate memory to store some value in there. So we have to set aside some space to put data in there. And then the second step is to actually put data into the allocated memory. So when we're allocating memory, we need to know where it is. I mean, if we just allocate some arbitrary space and have no way of pinpointing that space, it doesn't do us any good. So we need to know where that location is. Now, we could use the actual address itself, but in most systems, we're talking about long, complex hexadecimal numbers, and a hexadecimal is base 16 notation. So if you haven't heard that before, that's 0 through 9, and then letters A, B, C, D, E, and F. And that gets really complicated. So that's probably not the best way to go. So instead, we can use names. It's a lot easier for us to keep track of the memory that we've allocated, and it lets us know where that data is. So each name would be mapped to a specific address. Now, the important reason behind this, or at least one of the important reasons, is that some data should not be changed once we add it to memory. So we can use what we call named constants. And this tells a program that we're going to allocate a specific memory location, and once we put data in there, it cannot be changed. So how do we set aside this space? Well, to allocate memory, we use what we call a declaration statement. So let's take a look at an example of declaring a named constant. So this will be our format. So here we have 5 different things. We have final, type, identifier, an equal sign, and value. So let's break down each part of this statement. So final is a keyword that specifies that the value is fixed. In other words, I cannot change the value of my identifier once I put something in there. The type is simply going to be the data type of our constant. So this could be an integer, it could be a double, it could be a character, but this just lets us know what our data type is. The identifier is the actual name of our constant. And notice that we use uppercase letters for this. It's worth noting that it's not required. Most people would accept it that we would want uppercase letters for our named constants, but if you don't, you're not going to get a syntax error, you're not going to get a compile error, but it's just a way to distinguish between constants and non-constants. And then finally, value is simply the data that we're going to store in this memory location. So let me give you a complete example. So here we have final double pay rate equals 9.50. So what that means is I create a named constant called pay rate. It's going to store 9.50, and now I'm no longer allowed to make any changes to that constant. And notice that with pay rate, we include an underscore here to simulate a space. As you recall, a space is not a valid symbol in our identifiers. So what we can do instead, if we want to simulate this spacing, is just to include an underscore between the two words. In fact, this is a very common technique, and it makes reading identifiers a lot easier. So what if we need to change the data? So let's say we have our constant, and we need to change the value of that in our code. Well, the only way we can do that is if we just go into our source code, change it, and then recompile it. It's not like we can change it while we're running the program. Now, what that means if you have your constants declared at the very beginning of your code, you just change it from equaling to some value to a different value. Now, granted, this is better than changing the value everywhere in the code, which is the reason why we even have constants in the first place. Because if we just have the numerical values throughout our entire program, if we need to make a change, we have to change it everywhere. Whereas with the constant, we can just have it declared at the very beginning of our code and then change that one line. So it is better, but it still doesn't allow us to modify our data while we're running the program because, I mean, let's face it, there's going to be some data that has to be modified. And we call these particular memory cells where we do need to change it while running the program as variables. So let's take a look at the syntax of a variable. So we would have some type, and then we would have some name for a variable, and then we can put multiple variables together. So in this example, we have some type. Here type is just a placeholder, and then we can have ID1, ID2. We can have as many variables as we want. Unlike constants, notice that there is no final keyword. This is because, remember, with constants, we put the final in there to say that we cannot change the value. These memory cells contain values that we can change while we're running the program, so we don't want to include the final keyword. And we can declare multiple variables on the same line, as long as they're separated by commas. So kind of as we see here, there's a comma right here, we have one here, we have one here, and the elliptical dots there is just for demonstration purposes. Normally when you write your program, you would have every single variable there. It's just they're separated by commas. And notice that we also use lowercase letters. As I mentioned with constants, we're not required to use lowercase letters, but people recognize the difference between constants and variables by where constants have uppercase letters and variables have lowercase letters. But I mean, you technically could include capital letters in your variables if you wanted to. Now, what about multiple words? Because as we said before with identifiers, we can't have spaces in there. So what we normally do is we'll combine them into a single word. And all the first letters of each word except the first would be capitalized. Once again, you're not required to do this. Some languages would have you separate the words by using underscores. But in Java, most people would just combine the words without any spacing and put capital letters for each of the words except for the very first one. So let's take a look at an example here. So this would be a variable that we call amount due. So we have our type, which is the double, and then we have the words amount due. They're combined together and the D is capitalized, and then we end with a semicolon. Once we have declared a variable, we now need to use it. So how do we actually store data in these variables? Well, there are two ways we can go about it. One approach is to use what we call an assignment statement, and the other approach is to use input or read statements. Our focus right now will just be on the assignment statements. So what is that? Well, an assignment statement takes the following form. We would have the variable on the left side of our statement. We would have an equal sign, and then some expression on the right side, and then we end with a semicolon. Now it's important to note with an assignment statement that the types of both the expression and the variable must match. So for example, let's say I have an integer variable. My variable on the left side needs to be of type integer, and the expression on the right side must evaluate to an integer. I can only store an integer in an integer. I can't store a double into an integer. I can't store a character into a double and so forth. So the types must match. So when the statement actually runs, we evaluate what is on the right-hand side. We evaluate that expression, and whatever that result is, we store that in a variable. So I want to make something very clear. In most of your math classes, you would see this whole line, this whole formula, as like some equation saying that variable equals expression. But in computing, that's not what it is. That's not equality. We'll talk about later on how to deal with equality. But here what we're saying is take what's on the right-hand side and store it in the variable that's on the left-hand side. And then when a variable is assigned some initial value, we say that the variable is initialized. And I'm probably going to say this a lot, but it's very important to initialize your variables because otherwise who knows what's in there initially. So you do want to get into the habit of initializing them.